Hello everyone, in this video we will be covering part of chapter 6. We're going to start with parametric equations. What we do at the beginning is not really calculus, like the first part is also a review of pre-calculus. And then we have a new type of equations which are called parametric equations. We're going to do the same thing as regular equations, which is to take derivatives and to integrate. So now, if you remember from pre-calculus, a parametric equation is defined as you still have x, you still have y, which is the typical x and y coordinates. But now you have an extra parameter, which that's why it's called parametric equations. And in this case, here is the parameter. It's usually denoted by t, but it doesn't have to be t. So let's say we have the following two equations, x and y, which both of them clearly depend on t. So usually before, when you had to do a graph for x and y, you only have to have x and y and then the point x and y. However, now we're going to add the parameter t and see what happens. So if t is 0, well, x is going to be 3 times 0 plus 2, which will give you 2, and y will be 3. So this will give you the point 2, 3. If x is 1, this will be 5, and it will also be 5. You should check this. So this will give you the order pair 5, 5. And there's nothing special about these values. In theory, you can pick anything. I'm just picking small numbers because I want to do a graph, and I wanted to fit the graph. If, let's say that t was 2, then it will be 3 times 2 is 6, plus 2 is 8, and then this will be 2 times 2 is 4, plus 1 is 7, so this will give you the point A, 7. You can also pick a negative number, so this is negative 1, this will be negative 1, and this will be 1, so this will be the point negative 1, 1. All right, so let's say you wanted to graph these points. So the first one is 2, 3. So x is 2, y is 3. Remember that corresponds to time equals to 0. The next one is 5, 5, which will be here. And this will correspond to t equals to 1 or time. So t is usually denoting time. The other one is A7, which is out of the squares, but still it's fine. And the other one is negative 1, 1, which is here. So notice how this is technically a straight line, but now we want to use an arrow to denote the direction is going. So time is negative right here. This is time 0, time 1, and then this is time 2, and so forth. Now clearly this is a linear equation, so therefore it has to be of this form, y equals to mx plus b. So notice, so we have that 3t plus 2 is equals to x, and you solve for t will be equals to x minus 2 over 3. And then remember y was equals to 2t plus 3. So therefore, if you replace t by this will give you x minus 2 over 3 plus 3. And if you simplify, this will give you 2 over 3x plus 5 over 3. Where this is clearly the slope, and this is the y-intercept. Now this is not completely to scale, but you can check that this is practically 5 over 3. And then if you pick these 2 points, this is the rise, and this is the run. Okay, so let's look to a different type of equation now involving trigonometric functions, but it's the same idea. You will have a parameter, and you also have x and y. All right, so let's start with, let's say t is equals to 0. Remember, sine of 0 is 0, cosine of 0 is 1. So therefore, 1 minus 1 will give you, obviously, 0. So therefore, this first point will be 0, 0. Then let's use pi over 2. Remember that sine of pi over 2 is 1. Cosine of pi over 2 is 0. So it will be 1 minus 0, which is 1. And therefore, this will be the point 1, 1. And then let's go with pi. So this is pi. Sine of pi is 0. But cosine of pi, remember that cosine of pi is negative 1. So 1 minus 1 is 2. So this will be the point 0, 2. All right, so let's graph those 3 points. So at time 0, you will end up with 0, 0. So it will be t equals to 0. Then at time pi over 2, this will give you the point 1, 1. So let's say this is 1. So therefore, this will also be 1. And then at time pi, this will give you 2. So this will be 2. So this is t equals to pi over 2. And here this is t equals to pi. So you can see that you have something like this. Look, the graph is going this way. And the direction is to this side. Now you should check. So check yourself that you use pi over 3 and 2 pi. You're going to end up with an actual circle. So therefore, this x equals to sine t and y equals to 1 minus cosine t is technically a circle if you use parametric equations. Okay. Now let's verify that it's actually a circle using what we know from Cartesian coordinates, which is what we have used before. So if x equals to sine t, notice that x squared obviously has to be sine square t. And notice that y squared is going to be 1 minus cosine t squared, which if you expand it, this is 1 minus 2 cosine t plus cosine square t. Okay. Now notice, we already know that the equation of a circle, the x squared plus y squared equals to r squared, that this represents a circle. This is from pre-calculus. Okay. So everybody needs to remember this. So therefore, x squared plus y squared in our case is going to give us sine squared t plus 1 minus 2 cosine t plus cosine squared t. But remember that sine squared plus cosine squared is 1. So therefore, this will be 1 plus 1 minus 2 cosine t, which is equals to 2 times 1 minus cosine t. But remember that 1 minus cosine t is the same thing as y. So therefore, this is what we have so far. You have x squared plus y squared is equals to 2y. Or x squared plus y squared minus 2y equals to 0. So then if you complete the square, so if you complete the square, which hopefully you remember that, we have x squared plus y squared minus 2y. To complete the square, you had to add 1 to each side. So in this case, it's 0 plus 1. So this will be x squared, and this is y minus 1 squared equals to 1. So therefore, this is a circle where the center is 0, 1, and the radius equals to 1, which is not surprising because this is exactly what we have. This is the center, which is the point x is 0, y is 1, and the radius, you can tell that r is equals to 1. So therefore, this is not surprising. So the thing that is important here is that you need to know that this equation and this equation are exactly the same, except this is given in parametric equations. Well, this is called Cartesian equation. So it's very important that you know how to switch from one to the other, even though we're focusing on the parametrics anyways. All right, so now let's do actual calculus. And if we have parametric equations, remember that dy dx is what we call y prime. Is going to be defined to be dy. So notice that you have dy dt, and this is technically dt dx. So you can see that this will cancel, and you will end up with dy dx, okay, which is the definition we have all along. But now you find the derivative of y with respect to t. So t will be the independent variable, and do the same thing for x with respect to t, and then just the ratio of the two derivatives, that will be the derivative. Okay. Now to make our life easier, okay, this is notation from physics, but usually when you take the derivative with respect to t, instead of writing prime, I will write that. So this is the derivative of y with respect to t. So therefore, the derivative of x with respect to t is going to be x that. Okay. All right. So therefore, dy dx in our case, well, x that, we had to use the product rule here. So this will be 1 times e to the t plus t e to the t. So that's the derivative of x with respect to t. And then the derivative of y with respect to t will be 1 plus cosine t. So therefore, y prime, so note that y prime is going to be, remember, if we use this notation, it's going to be y dot over x dot. So this will be 1 plus cosine t divided by e to the t plus t e to the t. All right, so now that you know how to find derivatives of parametric equations, we can solve a problem like this. The question says find the equation of the line. Remember, the equation of the line is this: y minus y1 is equals to m times x minus x1. This is from algebra 1. So we have the x1 right here. So this is x1, and this is y1. The only thing we're missing is the m, or the slope. But remember that m is the same thing as y prime. So we need to figure out y prime, but to figure out y prime, well, we need to find x dot and y dot. So therefore from here, x dot is going to be 0 plus 1/2 t to the negative 1/2. And then y prime, or y dot is going to be e to the t squared times 2 t. The next part, and you have to be sure that you are careful with this part. So the 2e corresponds to which value of t, though. You have to be careful. And this one requires sometimes trial and error, but you have to verify what is the value for t, because you need it here to figure out the value for the slope. But notice that if t is 1, then y will be e to the 1 square, which is just e, and that's what we have here. And if t is 1, x will be 1 plus the square root of 1, which is 2. So therefore, the value of t is equals to 1. So if t is equals to 1, then that implies that x dot, it will be 0 plus 1/2, 1 to the negative 1/2, which is just 1/2. And then this implies the y dot is going to be equals to e to the 1 square times 2 times 1, which is technically just 2e. So therefore, y bar, which is the slope, remember, is equals to y dot over x dot. So in our case, it will be 2e divided by 1/2, which is equals to 4e. So then if we use now the equation, we're going to have y minus y1, which is e, is equals to m, which is 4e, times x minus x1, which is just 2. And that's technically good enough, but if you simplify, you're going to have y is equals to 4ex. Notice that this times that is technically minus ae. If you add 1 from the other side, it will be minus 7e. And this is the equation of the line. Now the formula for the second derivative is a little more involved. This is the formula. You can write it down and make sure you try to memorize it. Don't forget that dy dx, so remember this is what we were doing right now. This is the same thing as y dot over x dot, okay? So therefore you need to figure out the derivative of this first. And then once you figure out the derivative of this, you take the derivative of whatever you got with respect to t and divide by x bar. So that's the formula. So in our case, x dot is equals to minus sine t, and y dot, it will be 2 cosine 2t. Okay, so therefore from here, we have the y prime, which remember is the same thing as the y, the x, is equals to 2 cosine 2t divided by minus sine t. Now to take the derivative of this with respect to t, which is this par, so we need this, d of dt, this is what you need next, is 2 cosine 2t over minus sine t. So there are two ways you can do this. You can straight out use the quotient rule, or you can simplify this first and then take the derivative. So remember that this is the same thing as this. You can take out the constant. So this is minus 2 dt of cosine 2t over sine t. All right, so if you remember that derivative that you have f over g prime. Remember this is f prime g minus g prime f over g squared. So in this case, this will be sine squared t. F prime, the derivative of sine is cosine t. So it's cosine t times cosine 2t minus g prime, which is going to be plus 2 sine 2t times sine t. Okay, so that's this part, which corresponds to this. So therefore, the second derivative, so the second derivative of y with respect to x is going to be minus 2 cosine t, cosine 2t plus 2 sine 2t sine t over sine squared t, and everything divided by x bar. But x bar, remember, is minus sine t. Not x bar, x dot. Then this will simplify to just 2 cosine t cosine 2t plus 2 sine 2t sine t over sine qt. And actually you can simplify this a lot more, but this is okay for now. Remember that when we use Cartesian coordinates, you were able to find derivatives, to find integrals, and we also find the arc length. So there is a specific formula to find the arc length for parametric equations, and that's what we're going to do next. So this is the formula for the arc length from alpha to beta. Notice the similarity because the arc length before, so this was in chapter A, if I believe, is the integral from A to B of 1 plus f prime of x squared, the whole thing dx. So that was the previous formula. So now this is the formula for parametric equations. All right, so let's do an example. In our case, this will be alpha, and this is beta. So we need x dot, which is equals to e to the t minus 1, and y dot, which is equals to 4 times 1/2, which will give you 2 e to the t over 2. And then you need to square them. Make sure you check all the steps. If you square this will be e to the 2t minus 2 e to the t plus 1. And if you square this one, it will give you 4 e to the t. So therefore, if you add it up, x dot square plus y dot square, you will get e to the 2t. Notice that this plus that is just plus 2 e to the t plus 1, which is a perfect square, is e to the t plus 1 square. And perfect squares, you'll see right now, are very, very useful. So therefore, the arc length is going to be the integral from 0 to 2 of the square root of e to the t plus 1 square. So notice that the square and the square root cancel. That's why I say perfect squares are very, very useful. So this will be the integral from 0 to t of e to the t plus 1 dt. This is a very simple integral. This is e to the t plus t from 0 to 2. So this should be from 0 to 2, not 0 to t. So therefore, this will be e squared plus 2 minus e to the 0 plus 0. So therefore, this is e squared plus 1. So that's the answer. All right, so let's do one more. Here, you actually have two variables, r and t, but t is the parameter. And you'll see very soon in the next section, you can have more than one parameter. But for now, this is the parameter, just t. So we'll do the same thing. X dot is going to be minus r sine t. And y dot is going to be r cosine t. So if you square this, this will be r squared sine squared t. This one squared is going to be r cosine squared t. So therefore, x dot is squared plus y dot is squared. It's going to be r squared, and then you can factor the sine square and the cosine square, which we know this is equals to 1. So this is just r squared. So therefore, the arc length is going to be the integral from 0 to 2 pi of the square root of r squared, the r, which obviously this is just the integral from 0 to 2 pi of r, the r, or r dt. Remember that the variable here is t, not r, so therefore this will be rt from 0 to 2 pi, and once you plug it in, you will get 2 pi r, which this is no accident that this is 2 pi r. Remember, that's the circumference. From the previous example we did, remember that this represents a circle, and obviously you have a circle. The arc length is the thing around, which is what we call the circumference. So that's why there is no accident that the answer to this is just 2 pi r. Now, in 10.3, we're going to talk about polar coordinates, which is a very specific type of parametric equations. So remember, from trigonometry, this is x and y, this will be r. So this is the point xy in Cartesian coordinates. But remember, you can represent it also in polar coordinates. This is something you did in pre-calculus. So the connection is that tangent theta is the same thing as y over x. And from here, that means theta is equal to tangent inverse of y over x. So if you know the coordinates x and y, then you should be able to find the polar coordinates. Also remember that sine of theta is equals to y over r. So that means that y is equals to r sine theta. And in a similar way, cosine theta is equals to x over r. So that means that x is equals to r cosine theta. So if you know x and y, you can figure out the polar coordinates. The polar coordinates have two numbers or parameters, r and theta. So you know this, you can figure out x and y, and you have x and y, you can figure out this too. Now, just in case you forgot polar coordinates, just a quick reminder, you have to graph them. So remember, the first one represents the radius, and the second one the angle. So if you want to graph like pi over 4 and r is 4, so well, first go to pi over 4. Remember that pi over 4 is 45 degrees. So this is pi over 4. And then the radius is 4. So therefore this will be the first point. Let's call this A. So that will be point A. Then if you want 5 pi over 6, remember that 5 pi over 6 or pi over 6 is equals to 30 degrees. So therefore 5 pi over 6 is 150 degrees, which is right here. And then the radius is 5. So 5 is this line. So this will be the point. So let's call this B. Now be careful with negative values for r, which, you know, in theory a radius can be negative, but in polar coordinates you can have negative r. So let's say that letter C will be this minus 6 pi over 3. So first of all, if this was positive, remember pi over 3 is 30 degrees, which we say that already is pi over 3. So if this was the case, then the answer will be here 6 and 3. So this will be the answer if this was positive. But since that's not positive, then what you do is you go to the opposite line of this one, which will be 210 degrees in this case, and you go to 6. So 6 is here and 210 is there. So this will be right here. So now this will be the minus 6 and pi over 3. Now when you graph polar coordinates, it actually creates some really nice, very good looking graphs. So let's try some of those. So this one says that the angle or theta is between pi and 3 pi over 2, which you notice this is the third quadrant. So this is quadrant number 3, which is right here. So the answer has to be here. And then it says r is between 0 and 2. So since 2 is here, then the answer is just this. Not including the 2 technically, but that's it. Okay. While all of this represents this part. Okay. Now the ones that take more time are something like this, and you are welcome to use graphing calculators to do this. Usually the graph will just be given to you. You will not have to graph something complicated, but this is how you do it. So if theta is 0, this will be 1. Why? Because sine of 0 is 0 plus 1 will give you 1. Then you know that sine of pi over 2 is 1, so plus times 5 is 5, plus 1 will give you 6. So you should only use values that will give you precise values. If x is pi, remember the sine of pi is 0, so this will also give you 1 again. And if this is 3 pi over 2, will give you negative 4. And this is 2 pi, this will give you 1 again. Okay, so let's plug in the points. So if theta is 0, r is 1. Remember, this is theta equals to 0 is this line. And since this is 1, it will be here. So that's the first point. Then if theta is pi over 2, remember pi over 2 is 90 degrees. This one is equals to 6, which is right here. Then if theta is equals to pi, remember pi is right here. And this is positive, so it will be right here. And then this is 3 pi over 2. This one is 3 pi over 2, 270. See, if this was positive 4, the point will go here. But since this is negative, you have to go to the opposite side. So you have to go to 4, which is here. So 4 is here. Okay? And it doesn't look like match those 2 points, so you need to plug more points to see how it works. But the graph essentially is going to look like this. And like I say, this creates some pretty nice graphs, but it takes a long time to do by hand. So it's okay to use a graphing calculator to do these graphs. Or for now, you can use anything online just to create it so you can see how it looks. And there is a pattern for many of them. So once you see a few of them, you will kind of see how they're supposed to look. All right, so let's see how to change from Cartesian to polar and polar to Cartesian. So clearly this is in polar form. So notice this is what we have. R is equals to 4 over cosine theta. Why? Because secant is 1 over cosine. And therefore, remember that x is supposed to be equals to r cosine theta. So if you cross multiply, here we'll have 4 is equals to r cosine theta, which means that x is equals to 4. So if we're going to graph this equation, this will be 1, 2, 3, 4. So this is the line for this one, or the graph. This, or you can say x is just equals to 4. That's it. Now, if you have polar coordinates and you want to change it to, you have Cartesian coordinates and you want to change it to polar, all you have to do is use the substitution. So it will be 4r sine theta. Remember that's what y is, squared. And it will be equals to r cosine theta. So then this will give you 4r squared sine squared theta minus r cosine theta is equals to 0. And there is not a unique representation for this. You can write it in different ways. Here you can factor the r. So this will be 4r sine theta minus cosine theta equals to 0. Then r is either 0, you solve for this, or that means 4r sine squared theta is equals to cosine theta, which means that r is equals to cosine theta over sine squared theta. You can write this in different ways. You can also say that r is equals to 1/4 cotangent theta cosecant theta. You can check this. Okay, but this is good enough. All right, let's do this one more time. Remember that this is r cosine theta squared minus r sine theta squared equals to 4. So you can factor the r squared. This will be cosine squared theta minus sine squared equals to 4. Remember, there is an identity for this, that this is equals to just cosine to theta. That's from trigonometry. Equals to 4. So therefore, from here, r squared will be equals to 4 secant squared to theta. No, secant to theta, not square. Secant to theta. And that's it. Now to find the derivative is very similar to what we did with parametric equations, because these are technically parametric equations. So this is y that and this is x that. Just the formula is a little more involved because you have to use the product rule. Okay? But in this case, this is a typo, it should be theta. So to find y prime, well, now you have r and you have theta. So therefore, you need the derivative of r with respect to theta. So in this case, it will be 0 plus 3 cosine 3 theta. Notice that you already have the rest. You already have r, and you have cosine theta. You just have to plug it in. So therefore, from here, we have the y prime. It's going to be the r d theta, which is 3 cosine 3 theta, times sine theta, plus r, which is 2 plus sine 3 theta, times cosine theta. So this is this part right here. Then on the bottom, you have the r d theta, which we know is 3 cosine 3 theta, but now you're going to multiply times cosine theta, then minus r, which is 2 sine 3 theta, and now you multiply by sine. This is not hard, you have to be very careful with this. And then if theta is equals to pi over 4, you just have to plug in the values. If it doesn't ask you for that, then once you get to this point, you're good. So this is 3 times negative pi over, negative or equal to over 2, which is the value for sine theta and cosine 3 theta. Okay, so you should check this. So like I say, this is tedious, but it's not hard. And then just simplify the bottom two. Okay, times this and minus this. Then whatever that is. All right, let's move to the next problem. It says find the value of theta where the following curve has a horizontal tangent line. Remember that horizontal means that the slope is 0, which implies that y dot has to be 0. Remember that y dot is the r, the theta, sine theta, plus r cosine theta. So this is what we want it to be, 0. So the r, the theta, so this is what we want, okay, to give you slope of 0. The r, the theta is just e to the theta. So this will give you e to the theta sine theta plus e to the theta cosine theta, and this will be equals to 0. So this means that e to the theta, you can factor it, or you can move it to the other side, will be equals to, well, it's better to factor, it will be sine theta minus cosine theta is equals to 0. Notice that e to the 0 equals to 0, that never happens. So that implies 10.4 will be covered in a separate video.